All right, so here, a couple things about this warm-up here. The, Again, you can go either direction when you're doing that P1, P2. Like if you defined them differently, maybe your HA would be different than mine. I have two samples, each has for proportions, random, so it's dated for both. If you notice here, I wrote the normal check out a little bit differently. So I just wrote like the numbers that they kind of gave me up there. So the 80 successes for this age group, 98 for this age group, 49, 86. You can do it this way as well, it's just an alternative. So all are at least 10. Samples are independent. There's at least each of those groups right there. Those are my inputs to the calculator. P-value is greater than alpha. Fail to reject. There's not enough evidence to conclude, so if I'm not rejecting, I can't conclude that the proportion of 18 to 24-year-olds are comfortable talking about their feelings is greater than the 25 to 34-year-olds. Do the numbers justify? So no, the results are not statistically significant. So, time was saying that there was a difference. Here we're saying no. We could have committed a type 2 error because we failed to reject. Okay? All right, so the lesson today, we're doing the same thing that we kind of did for proportions, but now we're doing it for means. So if I ask you what's the meant by the sampling distribution of the difference between two means, it's all possible values of x bar 1 minus x bar 2 for a given sample size. So here's some, again, just like with the proportions. So this is x bar, I think these are males and females, this is from your book. So these are the x bars for the females, these are the x bars for the males. So then it took the difference in all those values there to create the distribution of x bar for the females minus x bar for the males. So here's your sampling distribution. Again, this is approximate, it says here, because it's not all possible values, but if I could create all possible values, in this case, the sample size is 12 for the females and 8 for the males. If I could create all possible samples of from those given sizes, that these would be the differences, or this is what the differences would look like. All right, the shape, center, and spread of the sampling distribution. So your shape is going to be approximately normal. Again, we've looked at this already with our one sample procedures, so it'll be very similar here. The conditions, again, random, normal, independent. All right, so the sampling distribution of x bar. So again, we're kind of going back to that stuff from chapter 6. So if you're taking the difference in two variables, to find the mean of the difference, you got to subtract the two means. If you want to find the standard deviation of the difference, you've got to find the variance of the differences. So you add the two variances together. So you also remember from chapter 7 that the mean of x bar is equal to mu, and the standard deviation of x bar is sigma over the square root of n. So if I want to find the mean of x bar 1 minus the mean of x bar 2, it's just like I'm taking the difference in the two means. Well, the mean of x bar 1 should just be mu 1, and the mean of x bar 2 should just be mu 2. So the mean is just mu 1 minus mu 2. To find the standard deviation, I'm going to first find the variance. So remember back from chapter 6. So the variance of this, so let's say for the first one, I would square it. I'm actually going to square the whole thing. And this is n1. So then what ends up happening here, when I square those, I end up with sigma 1 squared over n1 plus sigma 2 squared over n2. But again, this is the variance of the differences, the difference in the means. So if I want the standard deviation, I got to take the square root. The standard deviation of the differences would just be that Now, if I happen to be in a scenario in which I did know the population standard deviations, I could use this formula, and I'd use the z distribution. Most likely, I'm going to be in a situation in which I'd have to use the standard error. So I'll have to plug in my sample standard deviations into this formula. And when I'm in that scenario, that's when I'm using the t. So again, that's the standard error because I'm plugging the statistic instead of the parameter into the equation. Okay? Okay, the 4 steps here. So you want to state, so what parameter do we want to estimate it and at what confidence level? So we're doing the confidence intervals first. Identify the method. So today we're going to have a 2 sample t interval for means. Like I said, we're going to, using the z is just not realistic because you need to know sigma, and often we won't know sigma if we're trying to estimate the mean, okay? So we're going to go with t. The random, so again, you have 2 samples. So are they both random samples, or are they both randomly assigned? The sampling distribution. All right, so now we have different checks here. So are the populations normal? We have the central limit theorem. So are both samples greater than or equal to 30? If your samples are less than 30, let's look at the graph and make sure we have no strong skew or outliers. We still need independent samples. If this was not met, if not met, it would be a matched pair. We don't want a matched pair scenario here. Matched pairs are 1 sample procedures, which we did back in chapter 9. We want just 2 samples here. So we want 2 completely independent samples. Are the observations within a sample from an experiment with a random assignment? Are the observations within a sample taken without replacement? Check the 10% condition. So here's your formula. So again, remember it's the stat plus or minus the critical value times the standard deviation of the statistic. There's the calculator command. Do your interpretation. Okay, this T star right here. So if you remember back when we were doing 1 sample procedures. So our 1 sample procedures, the T star, we would use degrees of freedom of n-1. Well, now we have a problem here. We have 2 samples here. We don't just have 1, so we have 2 like n-1s because we have n1 minus 1 and we have n2 minus 1. So one way to figure out what degrees of freedom to use is to just take the smaller of the 2. The other way is to use this messy formula. You don't have to memorize this messy formula, but this is what the calculator will use. So the calculator is going to use it, and any other stat software packages are going to use that. The answers in your textbook are going to be using that conservative method. So the conservative method is just going to give maybe a little bit of a larger interval, and it'll give a larger p-value, okay? So here's an example. So do plastic bags from Target or plastic bags from Basha hold more weight? So we have a group of AP Stat students decided to investigate by filling a random sample of 5 bags from each store with common grocery items until the bags dripped. Then they weigh the contents of the items in each bag to determine its capacity. Here are the results in grams. Again, so you're going to start off with, your usual. We want to find a 99% confidence interval. For the difference in means. I'm doing a 2 sample t interval for means. Random. Yes, it's stated for both. All right, for the normal check, so I don't know, they're not bigger than 30. It doesn't say anything about the populations being normal. So I'm going to have to look at the graph here. So I'm going to type these into two separate ones, two separate lists. Unlike the matched pair procedure, I'm going to treat these as two separate lists. So I'm actually going to have two separate graphs. Okay, and I want to check something here to make sure I typed this all in correctly. Okay, I was just looking at my means. They're good. Okay, so I'm going to look at the graph here. I kind of like to look at the box plots because I can do two of them at one time. You can do two histograms at one time, but they just aren't always very, they lay them right on top of each other, so they're kind of hard to see. I guess I better use red for target. And then I'm going to go and do turn on plot 2. I'm going to use list 2. I'm going to create the box plot. And I don't know really what color bash this is. I'm going to use green. I'm going to go to zoom. I'm going to use that zoom 9. So there's my two box plots. Again, we only have 5 data points. And I'm not trying to prove that these 5 data points are normal. I am just trying to figure out, is it possible that they came from a distribution that is normal? Is it possible they came from a population that's normal? Is there anything here that makes me think the population might not be normal? I don't see any major skew. I don't see any outliers, so therefore I am not that concerned, okay? So I can say box plots show no outliers or major skew. Just like before, I'm going to sketch both of them. So the target one was the top one, and the bashes one is the bottom one. Independent. These are two separate grocery stores, so the samples are independent of each other. And then I'd have to assume for the 10% rule, at least 50 bags from each store. So then when I do my test here, so if I wanted to use the formula, I'd have to find all the pieces and plug it into the formula. This one, I'm just going to go straight here. So I'm going to use the data option, list 1, list 2, 1, 1. Just leave those as 1. This is going to be 9, 9. All right, this pooled right here, you just always say no. The pooled is, in the mean scenario, the pooled indicates if do you want to put the standard deviations together. So there's some textbooks teach that you work under the assumption that your two standard deviations are equal. So if you think they're equal, then you pool them. But our textbook doesn't do that, so we will always say no for pooled. We hit calculate. I get this interval. You didn't have to type in the inputs here because we used the data option, so I'm going to give the outputs. And here's my answer. Oops. And then, my typical statement. 72845 grams captures the true mean weight difference between the two, weight difference of capacity between the two brands. Does your interval provide convincing evidence that there is a difference among the two stores? So no, because 0 is in the interval. Okay? And that is that for this lesson.